I have a question. How many GPS satellites have been deployed in space?
The USA maintains about 30 working GPS satellites that orbit the Earth. Some of these satellites are for backup purpose. Currently, there are 4 global navigation satellite systems in use worldwide. The GPS of USA, the GLONASS of Russia, the Galileo of Europe, and the Beidou of China. There are also 2 regional systems, the QZSS of Japan, and the IRNSS, or NavIC of India.
How does SPAS work?
The Regional Satellite-Based Augmentation Systems, or SBAS, employs the Relative Positioning Method. There is the Wide Area Augmentation System, or WAS, in the USA, and there is the Geostationary Navigation Overlay Service, or EGNOS, in Europe. A satellite-based augmentation system usually consists of a number of surveyed ground reference stations, spread over a country or a continent. The GNSS errors measured at these stations are transferred to a center for computing differential corrections and data integrity. This information is then broadcast via satellites to SBAS-enabled GNSS receivers to provide sub-meter horizontal position accuracy.
What is RTK?
RTK stands for Real-Time Kinematic. With this method, accurate correction data is computed by a network of high-precision receivers, placed at surveyed base stations, and broadcast via radio. An RTK receiver is able to apply the differential correction data stream from the RTK network to the GPS signals, and compute locations, accurate to 1 centimeter in real time, even while the RTK receiver is in motion. The high cost of RTK receivers limits their use to work requiring high position accuracy, such as land surveying, and high-accuracy data collection.
What is assisted GPS?
The assisted GPS, or AGPS, on smartphones is helped by a server with a reference GPS receiver that has clear view of the sky and monitors the same satellites that the GPS on the cellular device monitors. Ephemeris data and other assistance data are sent from a network of surveyed cell towers to the integrated GPS on the smartphone. As a result, the smartphone GPS is able to quickly get a GPS fix, even when the signals from the satellites are weak. However, these smartphones do not offer high position accuracy.
Corresponding to the different methods of GPS positioning, there are different types of GPS receivers that offer different levels of accuracy. Of course, you will want to use the most cost-effective GPS system that is within your budget and also meets the requirements of your application. CA code receivers typically provide 1 to 5 meter GPS position accuracy with differential correction. CA code GPS receivers provide a sufficient degree of accuracy to make them useful in most Geographic Information System applications, or GIS applications. CA code receivers can provide 1 to 5 meter GPS position accuracy with an occupation time of 1 second. Longer occupation times, up to 3 minutes, will provide GPS position accuracies consistently within 1 to 3 meters. Recent advances in GPS receiver design now allow a CA code receiver to provide sub-meter accuracy down to 30 centimeters. Carrier phase receivers typically provide 10 to 30 centimeter GPS position accuracy with differential correction. Carrier phase receivers provide the higher level of accuracy demanded by certain GPS applications. A long occupation time is required to attain the 10 to 30 centimeter accuracy. Initializing a carrier phase GPS job on a known point requires an occupation time of about 5 minutes. Initializing a carrier phase GPS job on an unknown point requires an occupation time of about 30 to 40 minutes. In addition, using the carrier phase method requires you to maintain the same satellite constellation throughout the job and be fairly close to a base station. These requirements make carrier phase receivers impractical for many GPS applications. Dual frequency receivers receive signals from the satellites on two frequencies simultaneously. They are capable of providing sub-centimeter GPS position accuracy with differential correction. Dual frequency receivers provide survey-grade accuracies not often required for GIS applications.
How accurate are the SBAS-enabled GNSS receivers?
SBAS-enabled GNSS receivers, such as the Dulex GPS 150A and the Bad-Elf GPS, can provide accurate and reliable GPS coordinates within 2 to 5 meters. These affordable recreational-grade GPS receivers are mostly used in navigation applications.
Which GNSS receivers provide sub-meter positional accuracy?
The Juniper Geode, the EOS Aero 100, and the GNEC SX Blue 2 are iOS-compatible, mapping-grade GNSS receivers. These units can provide sub-meter real-time positional accuracy. In addition, high-end iOS-compatible GNSS receivers, such as the EOS Aero Gold and the GNEC SX Blue Platinum, are able to process RTK corrections from RTK networks. This way, they can achieve centimeter-level accuracy in real time for land surveying and high-accuracy positioning applications.